Hey guys, so today we're going to talk about fronts. What are fronts? So, fronts are boundaries between different types of air masses. It's when two different types of air masses meet. What we're focusing on today are warm and humid air masses, and when they meet cold and dry air masses. The reason we're talking about warm, humid air masses meeting cold and dry air masses is because that's when they form rain and precipitation. Okay? So make sure you have your note packet out and go ahead and write these notes down, whether it's the short atmospheric state and they create fronts. And you're also given this diagram here about the different types of fronts. So the fronts are the different types of fronts and their symbols are actually found on your reference table, page 13. So make sure you have that out. We are focusing on four different types of fronts: cold fronts that are represented with these triangles, warm fronts represented with these semicircles, stationary fronts represented with both the triangles and semicircles in opposite directions, and occluded fronts with triangles and semicircles in the same direction. You don't have to memorize this, it's on your reference table. So, I want to show you a simulation, and maybe that will help you understand this more. And this is the website I'm using if you want to refer to it. But this website shows the different types of fronts. So, let's start with a cold front. So, a cold front is the transition zone between two air masses of different densities, and in this case, when cold air and warm air meet. So, it's when cold air is pushing towards warm air, and watch what happens. So, the cold air is pushing towards warm air, and remember, warm air is less dense, so it's going to rise. And as warm air rises, it starts to cool down um, and condense to form these clouds as well as rain. And notice the cold air is represented by these triangles, just like your reference table. And the direction of these triangles show which way the the cold front is going. In this case, it's going towards the right. Okay, just like this. Also, notice the clouds and precipitation are forming exactly where the symbols for the front are. Not here, not here. Also, cold air is normally cool and dry. Right behind this right behind this front is very cool and dry. And right in front of this front is very warm and humid. So I can ask you, what's the type of weather over here? You would say cool and dry. What about on this side? Warm and humid. What about right in the middle of the front? Very warm, very humid because of all the rain. Okay? And the cold area of the front, the cold and dry, is moving, right? Because the cold air is pushing towards the warm. What about warm fronts? Well, in warm fronts, this time the warm air is pushing towards the cold air. Okay. And remember, warm air is less dense. And so, as the warm air is pushing towards the cold air, since it's less dense, it's still going to rise. And as it rises, it starts to form clouds and precipitation. I know the clouds and precipitations are showing here, but normally the clouds and precipitation will form over the symbols for the front, okay? Or near the symbols for the front. And wherever there's warm air, right behind the front is where we have warm and humid air. Right in front of the front is where I have cold air, right? This area will have cool and dry air. But as the warm air is pushing towards the cold air, more areas will be warm and humid rather than cold and dry. So the difference between a cold front and a warm front is that in a warm front, the warm air is pushing towards the cold air, and in a cold front, the cold air is pushing towards the warm air. In both cases, the warm air is rising and creating clouds and precipitation. The clouds and precipitation are normally found around the front area. Okay. And the semicircles here are showing the direction of the front. The front is going towards the right once again. Next, let's talk about an occluded front. So, in an occluded front, we have cool air moving towards cool air, and while that's happening, warm air is being trapped in the middle. The warm air was already there, and as the cool air is pushing, notice that the warm air is just trapped and it's still rising up, and once again, forming clouds and precipitation right where the front symbols are. The semicircles and triangles that you can find in your reference table, you don't have to memorize the symbols, but they show the direction in which the cool air or the front is moving. So in this case, towards the right, once again, wherever I have cool air, right behind that front, in this case, it's cool and dry, and wherever I have warm air is warm and humid. Notice in an occluded front, we're actually creating two different types of fronts. For instance, notice on this side, the cool air is pushing towards warm air, and that is actually what a cold front is, right? Cool air pushing towards warm air, causing it to rise. But on this side, notice that the warm air, because the cool air is pushing this way, on this side, the warm air is actually pushing towards cool air and rising. We're creating a warm front here. So we have a cool front here and a warm front here, causing the warm air in the middle to rise and cause rain and precipitation and clouds. We call this an occluded front. You might be asked, what kind of front is on this side? That's a cold front because the cold air is pushing towards the warm air. And what about this side? Well, this is a warm front because the warm air is pushing towards the cool air. In both cases, the warm air is rising, causing clouds and rain. Lastly, we have a stationary front. In this type of front, cold air and warm air meet, but they don't have enough energy to keep pushing into each other or causing either one the warm air to rise up. So in this case, they kind of stay stagnant or stationary. Stationary means still; they're not really moving, and they're represented by semicircles and triangles in opposite directions. They're not really moving, although they're trying to. The warm air is going this way, cool air is going this way, and they stay stagnant. They still cause clouds and rain to form where the front symbols are. This side of the front is warm and humid, and this side of the front is cool and dry. All right, let's go back to our notes. So this is a refresher of what I just talked about. This is a symbol for cold front in your reference table. In a cold front, cold air pushes towards warm air rises. We get clouds and rain where we have these symbols right here. The arrow point towards the direction the front is going towards. Behind the cold front, we have cool and dry air. In front of the cold front, we have warm and humid air where the warm air is being pushed up. In a warm front, we use this symbols. It's from your reference table, page 13. In a warm front, warm air is pushing towards cold air. Once again, wherever we have the front symbols, we have clouds and precipitation. It's very rainy. On this side of a warm front, since it's the warm air side, it's warm and humid. On in front of the front is a cold air, so it's cool and dry. Next, we have an occluded front. We use this symbols from your reference table of page 13. Wherever we have the front symbols is where we have clouds and rain. On this side where we have cold air is cool and dry. On this side we have cold air, so it's also cool and dry, and these areas are warm and humid. Notice we're creating two types of fronts. On this side we're creating a cold front. Cold air is pushing warm air up. And on this side we're creating a warm front. Warm air is pushing towards cool air and rising up. Lastly, a stationary front is you represented by these symbols from your reference table, page 13. It's when cold air and warm air don't have enough energy to push the warm air up, but we still get clouds and rain wherever I have the front symbols. In the warm side, we have it's warm and humid, and in the cold air side, it's cool and dry. But neither of them are really moving. And this is in your note packet right here if you need to refer to any of the different types of fronts that we talked about.